All right, ladies and gentlemen, welcome back. We're going to be talking about dilations for today. And with dilations, our key focus, or what we're going to start with, is our definition. So, a dilation is a transformation that produces an image that is the same shape as the original but a different size. A dilation is similar to the original figure but not congruent. Dilations are centered around the origin, which we know is 0, 0, unless otherwise stated. A scale factor is the image length divided by the pre-image length, which is a ratio. So scale factor is very important. Okay, in order for us to understand that we are doing a dilation, they're going to give us a scale factor, or they're going to ask us to find a scale factor. So that's a key word that we look for, so we know that we're doing a dilation, which is the word scale factor. And if we do see the scale factor, it says if a scale factor is greater than 1, the figure is going to get larger. If the scale factor is between 0 and 1, it's going to get smaller. And the last key fact that we need to know about scale factor says if the scale factor is 1, the figure stays the same size. All right, so just so we know and get a clarification, when I say between 0 and 1, we're looking at what can be considered to be a regular fraction. And what I mean by regular fraction is no improper. The top number, which is your numerator, is smaller than your denominator. Okay, that is what I consider to be a regular fraction. Now, as we move in to our actual examples, the first example we're going to discuss deals with the rule. And the rule states that if we have x and y, which is the point that they give us, what we're going to do is take f and x and f and y. Well, the f represents the scale factor. That's a symbol that we use to represent scale factor. But what I want to focus on is you see that the f and x are side by side and the f and y is side by side. And what that means is that whenever you see two letters side by side, that means we're going to multiply. So whatever our scale factor is, we're going to multiply by that scale factor. Okay? So just know with the rules, if we see two letters side by side or a number and a letter side by side, that means we're going to multiply. So for example, when it says if the scale factor is 3, how would you write the rule? So if we're looking at that, we take the original order pair, and to apply the scale factor, we're going to take it and multiply it to the x. We're going to take that 3 and we're going to multiply it to the y. Okay, you can also see it as 3x and 3y, and that's the same thing. Okay, but the key thing to know is that we're going to be multiplying. So example 2, it says triangle ABC has the vertices of A, which is at 0, 2, B, which is at 4, 4, and C, which is at negative 1, 4. It says what will be the vertices of the image with a scale factor of 4. There's that word again, scale factor. So anytime we see the word scale factor, we know we're going to be multiplying. Okay, we have to remember that. Scale factor of 4. So if we write that rule, the rule is going to tell us that we're going to do 4 times x and then 4 times y for all points. Okay, the first point they gave us was 0, 2. So if I take and multiply all that by 4, 4 times 0 is still 0. 4 times 2 is 8. 4 times 4 is 16. And then 4 times 4 again is 16. Negative 1 times 4 is going to give me negative 4. And 4 times 4 again is going to give me 16. So that's how we get the answer when we have a scale factor that is, remember, greater than 1. We noticed that it started with small numbers and then the numbers got bigger. So that means when the number or a scale factor is greater than 1, the number should get bigger. Okay, so let's move to example 3. In example 3, it says the quadrilateral PQRS has the vertices of P, which is at -2, 4. So let's go ahead and graph it. -2, 4. That's going to be P. 4, 4. All right, so that's Q. We got 4, -2. That's R. And then we have -4, -4. And that's going to be point S. So let's connect these points. So if I connect my points, it's going to make some kind of image. It kind of looks like a kite. With the images or the points connected, it says it is dilated by a scale factor. There's that word, scale factor, of 1/2. It says what are the coordinates of the image, and then we're going to graph them. Okay? So if we take the points that we know, what they gave us, and we plot them out. So the first point that we have was -2, 4. But the rule states that we got to take 1/2. Okay, so I'm going to write the rule up here. So we got X and Y, which is the points they gave us. We're going to take and multiply every point by 1/2. If I take 2 and multiply it by 1/2, just think about it. If I take half of 2, that's going to be 1. So the first order pair we're going to get is -1. And if I take 4 and take half of that, that's going to give me 2. So that's going to give me P prime. Okay, the next point we have is Q. Q is at 4, 4. If we put our thinking caps on 4, half of 4 is 2. So that's going to give me 2, 2 at Q prime. The next point we have is R. R is at 4, -2. Just thinking about it again, half of 4 is 2. Half of -2 is -1. And that's going to give me R prime. And the last point we have is S. And S is at -4, -4. And that point, when we graph it, is going to be at -2, -2. And that's S prime. So let's put it on the graph to see what it actually happened. So first point, P prime is at -1, 2. Q prime is at 2, 2. R prime is at 2, -1. And S prime is at -2, -2. So if we connect those points, we notice what happened was that the image actually got smaller. So because the image got smaller, the key thing that we noticed when we talked about the scale factor is 1/2. Whenever I have a fraction or considered to be a regular fraction, it makes the image smaller. So that's what happened. So let's move to the next example, example 4. Looking at example 4, we just want to label whether we have a enlargement or reduction. It says if the scale factor is 5/2, is it an enlargement or reduction? And how do we know? So you remember when I talked about the regular fractions? Regular fractions have a smaller number at the top and the big number at the bottom. But if we look at this one, we have the larger number at the top. Smaller at the bottom. Because that happened, that is an improper fraction. And because we have an improper fraction, improper fractions, when changed to decimals, give us a whole number. Sometimes that whole number is bigger than 1, sometimes it is 1. So if we look at 5/2 and we change 5/2 to a fraction, well, from a fraction to a decimal, we get 2.5. 2.5 is definitely bigger than 1. So because 2.5 is larger than 1, that will be an enlargement. And that's how we know. So 2.5 is larger than 1. It says if the scale factor is 3/8, is it an enlargement or a reduction? How do we know? Okay, so if we look at this one, this is smaller. This is larger. So here when we have the smaller at the top, larger at the bottom, this is what I consider a regular fraction. Because I consider that a regular fraction, and fractions we just learned is going to make it smaller, so that's going to be a reduction. So that's how we know a regular fraction is less than 1. So that's going to make it smaller, reduction. All right, so let's move to now example 5. It says triangle LMN will be dilated with respect to the origin by a scale factor of 1/2. What will be the coordinates of triangle for L prime, M prime, and N prime? So we're looking at a scale factor of 1/2. With the scale factor of 1/2, we're going to write the rule. So we got 1/2 times x, and we're going to have 1/2 times y. But now they didn't give us the order pair, so they just gave us a graph. So let's go find out what our order pairs are. So the order pair for L is going to be -3, 4. For M, we got 3, 4. And N, we got 3, 1. Okay, so if I take the points that they gave us, multiply it by half, we'll get our actual new image that we should have. So let's look at it. If I take L, which we know is at -3, 4, multiply it by 1/2. If I think about what is half of 3, just like money, if I had $3 and I spent half, I got 1.5 left. And that was a negative, so that's a -1.5. If I think about what is half of 4, that's going to give me 2. So that's going to be 2. Now that's going to give me L prime. Then the next one we got M. M we said was at 3, 4. Same concept. Half of 3, 1.5. Half of 4 is going to be 2. And that's going to be M prime. And then the last one, which is N, it's just 3, 1. If I think about what is half of 3, that's 1.5. We did that a couple times already. Then I think about what is half of 1. So if I have $1 and I take half $1, that's 50 cents. So I'm put 0.5. And that's going to be N prime. Now it's kind of hard to graph decimals, so we're just going to take it as the list. And if it was a multiple choice, we'll look at our list and match our list to what they have for the answer choices. All right, so now let's look at our last example, which is example 6. In example 6, it says rectangle MNOP was dilated, producing a rectangle M prime, N prime, O prime, and P prime. It says what is the scale factor was applied to the rectangle MNOP to produce rectangle M prime, N prime, O prime, and P prime. So we know the one with the prime symbol is what it moved to. So it started here and ended here. So just looking from where we start to the end, we notice that it got bigger. So because it got bigger, that means the scale factor has to be a number greater than 1. Okay? So if that's the case, we know it's going to get bigger, so we got to find out what that scale factor is. So in order to do that, we pick 1 point off the figure. Because of that, we have to remember that with dilations, it makes it either bigger or larger. So that means the points are not necessarily in the same spot, but we can use a number to get the bigger number or the smaller number that it is, whether it be a fraction or a whole number. So, and every point is going to be multiplied by that scale factor. So that means we don't have to do all points. We just got to find one and then figure out what happened to it. So if I find out what N is at +1, 2. Then I got to go to my end and find the point for N prime. And N prime ended up at 3, 6. So something happened to 1, 2 to become 3, 6. And what we have to realize is what number, because we know scale factor means multiply. What can we multiply to 1, 2 to get it to become 3, 6? So if we think about it, using our multiplication, 2 times what will give me 6? And 1 times what will give me 3? So 2 times 3 will give me 6. And 3 times 1 will give me 3. So that means what I have is if I take both of those numbers for 1, 2, and times it by 3, it's going to give me the point that for my image. So my scale factor is 3, because that's the number that I can use to multiply to both of my original points, which is 1, 2, and get my new points, which is 3, 6. Okay, so that's how we use dilations on the coordinate plane. Have your questions ready.